In 1995, the Hubble Space Telescope turned toward a tiny patch of sky that looked empty. No bright stars, no obvious galaxies, just a dark region so small and unremarkable that it seemed unlikely to contain anything worth seeing. Then, Hubble kept staring. Hours passed. More light accumulated. The darkness began to change. What looked blank at first started filling with faint points of light. Then more appeared. Then more. By the time the image was complete, that supposedly empty patch of sky contained thousands of galaxies packed into a space that had looked completely vacant. The result created an immediate problem. Empty space could no longer be trusted to be empty. The sky had not changed. The galaxies had been there the entire time. The only thing that changed was the ability to see them. A region that appeared exhausted of discovery suddenly became crowded with structure. Darkness stopped meaning absence. Blankness stopped meaning nothing was there. The map of the universe was no longer missing a few details. It was missing entire landscapes. And if thousands of galaxies could hide inside a patch of sky that looked empty, it raised a far more unsettling possibility. How much of the universe was still waiting beyond the limits of what anyone could currently see? The simplest explanation was that the first image had been a lucky accident. Maybe that tiny patch of sky happened to contain an unusual concentration of galaxies. Maybe the surprise was real, but limited. So astronomers looked again. They pointed their instruments at other regions, different locations, different stretches of apparently ordinary sky. The same pattern returned. Images that began as sparse collections of faint light gradually filled with structure. More distant galaxies emerged. Then larger populations appeared behind them. Areas that seemed nearly exhausted of visible objects kept revealing additional layers once enough light had been collected. The first image could be dismissed. The second was harder. By the time the pattern appeared again and again, the explanation was running out of places to hide. The assumption that the deep field had simply gotten lucky became harder to defend every time another, supposedly ordinary region produced the same outcome. What changed was not the sky itself. What changed was how much of it could be detected. The sequence became familiar. An apparently empty region was examined more closely. Hidden structure appeared. The observation went deeper. More appeared behind it. Hidden structure was no longer behaving like an exception. It was starting to look like a recurring feature of observation itself. And that created a new problem. If deeper surveys kept exposing large populations that had been missed before, why did every new look continue finding so much more? The pattern created a reassuring explanation. If deeper observations kept revealing hidden galaxies, then the problem was probably not the universe. The problem was the equipment. Each generation of telescopes pushed farther than the one before it. Faint points of light became visible. Distant structures sharpened. Regions that once looked sparse filled with new detail. The frontier kept moving outward because the tools kept improving. That interpretation fit everything people were seeing. A survey reaches a limit. A stronger telescope arrives. More galaxies appear beyond the previous boundary. Another instrument pushes deeper. More of the map comes into view. After enough repetitions, it no longer felt surprising. What seemed invisible eventually became visible. What looked beyond reach eventually moved onto the map. Every improvement appeared to shrink the unknown. The expanding inventory of galaxies no longer felt threatening. It felt temporary. The missing pieces appeared to have a practical cause and a practical solution. Build a better instrument. Collect more light. Push farther into the darkness. The universe was not refusing to reveal itself. Humanity simply had not built powerful enough tools yet. And if every new generation could reach beyond the last one, the conclusion seemed straightforward. Sooner or later, the technology would catch up. The hidden regions would become visible. The remaining gaps would continue shrinking. The only question was what would happen when there were no more limits left to push beyond. The logic seemed solid. If every generation of telescopes revealed things the previous generation could not see, then eventually the hidden inventory would shrink. The surprises would become smaller. The gaps would become fewer. Better tools would gradually finish the job. Then, the James Webb Space Telescope began returning images. This was supposed to be the moment the pattern started slowing down. A more powerful telescope should reveal fewer surprises, not more. The frontier could still move outward, but the unknown was supposed to start losing ground. Instead, new observations kept producing additional territory. Images reached deeper than before and revealed structures that looked more developed than many expected to find so early in cosmic history. Regions that were supposed to become clearer often became more complicated. New observations did not simply fill blank spaces on the map. They created new sections of the map that had not been anticipated. The pattern returned immediately. The telescope pushed deeper. The map expanded. It pushed deeper again. The frontier expanded with it. The old explanation began to weaken. The problem was no longer that earlier instruments had missed a few details. The problem was that every major improvement seemed to uncover another layer waiting behind the previous one. The frontier was still moving. The surprise was that it showed no sign of slowing down. The assumption that better technology would steadily reduce major discoveries became harder to maintain. Each advance was supposed to convert unknown territory into known territory. Instead, the known territory kept expanding alongside the unknown. The map was growing. But completion was not getting any closer. And if every successful exploration opened additional frontiers instead of closing them, an unsettling possibility began taking shape. What exactly does exploration become when discovery keeps creating more territory to explore? The pattern no longer pointed toward a finish line. Every time astronomy reached what looked like a boundary, technology improved and transformed that boundary into a starting point. A limit became a doorway. A frontier became a map. Then the new map revealed another frontier beyond it. The process repeated often enough to change what exploration appeared to be. The expectation had always been straightforward. Keep improving the tools. Keep filling the gaps. Eventually, the unknown territory becomes small enough to define, measure, and complete. But the observations kept moving in a different direction. Every discovery expanded the map, but every expansion revealed a new edge. The farther astronomers pushed, the more horizon appeared in front of them. Progress was real. Arrival never was. What changed was not humanity's ability to explore. What changed was the assumption that exploration leads toward a completed map. The deeper the search went, the more the universe behaved like a landscape that continually revealed additional layers beyond the previous horizon. Not because the effort failed, because the effort succeeded. The result is a different picture of discovery itself. Humanity may not be moving toward a finished map. It may be chasing a horizon that retreats every time it is reached. Every answer reveals more territory. Every frontier becomes another beginning.